All right, so get this. We're talking about a cyclone that decided to chuck the rule book out the window and slammed into a place that basically never sees this kind of weather.
Yeah, crazy.
Yeah. Today, we're going deep on the story of Cyclone Alfred, which surprised everyone by hitting near Brisbane, Australia in March of this year.
You know, it's incredibly rare for cyclones to reach that far south.
Really?
On the east coast of Australia. The last time anything even remotely close to this happened was way back in 1974 with Tropical Cyclone Zoe.
Wow.
Yeah.
Okay, so we're diving into this NASA Earth Observatory article titled, "This Cyclone Broke Every Rule, and Now It's Wreaking Havoc," published on March 10th, 2025.
Right.
What was the initial setup here? Like, what happened first?
So Alfred first kind of popped up on the radar out in the Coral Sea on February 22nd.
Okay.
At first, it just looked like it would fizzle out at sea like so many cyclones in that region do.
Right, yeah.
You know,
Yeah.
get a peter out.
Yeah, right.
But then things took a turn.
Oh.
You know, what happened?
What happened?
On March 4th, Alfred did something totally unexpected.
Oh.
It made this like sharp westward turn, just completely throwing off all the early forecasts.
Oh, really?
Yeah.
Okay, so what caused this sudden shift?
Yeah.
Why did Alfred decide to break all the rules?
So the article points to this high-pressure ridge that formed south of the cyclone.
Okay.
Essentially, this ridge acted like this giant atmospheric wall, pushing Alfred towards the coast instead of letting it drift out to sea.
Interesting. So instead of dissipating over open water, it got steered directly toward land.
Exactly.
Wow.
And to add to the complexity, predicting the behavior of cyclones in the Coral Sea is incredibly challenging.
I bet.
The wind patterns and weather systems in that region are notoriously fickle.
Right.
Even with all of our sophisticated technology, we're still working on fully understanding how they interact.
So Alfred was already a bit of a mystery from the start.
Yeah, kind of.
The article mentions that while it wasn't the most powerful cyclone on record, its impact was significant because of how slowly it moved. Can you explain how the speed of a cyclone affects its impact? Like, why is that such a big deal?
Yeah, so think of it this way. A fast-moving cyclone is like a quick punch,
Okay.
delivering a burst of intense energy.
Right.
But a slow-moving cyclone, like Alfred, is more like a constant battering ram.
Oh.
It just lingers over an area, subjecting it to prolonged periods of heavy rain, strong winds, and storm surges.
I see. So even if the winds aren't as strong as a Category 5 hurricane, the sustained exposure to those elements can cause significant damage.
Exactly.
What are storm surges exactly?
So storm surge is basically a rise in sea level caused by the powerful winds of a cyclone pushing water toward the shore.
Okay.
It can lead to widespread coastal flooding, especially in low-lying areas.
Oh, so it's not just the rain that's a concern, but also this wall of water being driven inland.
Yeah, right.
That explains why the article talks about coastal erosion and major flood warnings issued for populated areas like Brisbane, the Gold Coast, and Byron Bay. These aren't exactly places known for dealing with cyclones, are they?
No, they're not. Brisbane, in particular, is very unusual for a major city to be hit by a cyclone.
Right.
The last time anything even remotely close to this happened was, like I said, over 50 years ago.
Wow, so that's got to be a shock for the residents.
Absolutely.
So we've got this rare cyclone taking an unexpected path and lingering off the coast, bringing all this rain and storm surge with it.
Yeah.
The article also mentions that Alfred was fueled by unusually warm ocean temperatures.
Right.
How does that play into the intensity of a cyclone?
Well, warm ocean water acts as fuel for cyclones.
Okay.
The heat energy from the water evaporates, rises, and feeds the storm circulation.
Okay.
So the warmer the water, the more potential energy the cyclone can draw on, potentially making it stronger.
So it's like a feedback loop.
Yeah.
Warmer water leads to a stronger cyclone, which in turn churns up the ocean, potentially leading to even warmer surface temperatures.
That's a great way to put it. And in the case of Alfred, the Northeast Coral Sea was experiencing, they could measure the intensity of the winds by analyzing cloud patterns and even track the movement of the storm surge as it approached the coast.
So this satellite imagery wasn't just about taking pretty pictures.
No, definitely not.
It was providing vital data that helped scientists understand what was happening and make more accurate forecasts.
Exactly. In a situation like this, where a cyclone is behaving unpredictably, having access to real-time data from satellites is absolutely crucial.
Wow.
It allows us to monitor the situation closely and potentially provide more timely warnings to those in harm's way.
Right, yeah. It seems like having multiple ways of looking at the cyclone, like from satellites to like on-the-ground observations.
Yeah.
Was really key to understanding what made Alfred so unique.
Absolutely. And one of the things that really stood out to me was those unusually warm sea surface temperatures we talked about earlier.
Right.
They kind of add another layer of complexity to the whole story.
Yeah.
You know?
Yeah.
Because that extra heat in the water can really amp up a cyclone's intensity.
It's like giving the storm like an energy boost, right?
Exactly.
The warmer the water, the more fuel the cyclone has to draw on.
Precisely.
Yeah.
And that raises an interesting question about the role of climate change in all of this.
Okay. Yeah.
While it's difficult to directly link any single weather event to climate change,
Right.
we do know that warmer ocean temperatures create conditions that are much more favorable for intense cyclones to form.
So it's not necessarily causing more cyclones,
Right.
but it could be making the ones that do form more powerful and potentially more destructive.
That's the general idea.
Hmm.
And the impact of a more intense cyclone is clearly visible in the damage Alfred inflicted on Queensland's coast.
Yeah, the article highlights the coastal erosion, flooding, and those major flood warnings issued for several rivers.
Right.
It paints a picture of a pretty chaotic situation.
Yeah, it was.
What are some of the long-term effects of this kind of damage?
Well, beyond the immediate threat to life and property during the storm itself,
Right.
there are these sort of like long-term consequences like disruptions to infrastructure.
Right.
Displacement of communities and like huge economic losses.
Yeah.
Rebuilding after an event like this can take months, if not years.
Yeah, and we have to remember that Brisbane isn't a city that typically braces for cyclones.
No,
This must have been a particularly jarring experience for residents.
absolutely. When a community isn't accustomed to dealing with cyclones, the impacts can be much more severe.
Right.
People might not have the same level of preparedness or infrastructure in place to handle a cyclone
Yeah.
compared to areas where these storms are more common.
So it's not just about the strength of the cyclone itself,
No.
but also about the context in which it occurs.
Right.
And the vulnerability of the communities and its path.
Exactly.
What stands out to you as like the biggest takeaway from this whole event? Like if you had to boil it all down to one key lesson, what would it be?
I think one of the key lessons here is the importance of resilience.
Okay.
We need to build communities and infrastructure that can withstand the impacts of these increasingly intense storms.
Resilience is a word we hear a lot these days.
Yeah, for sure.
But what does that actually look like in practice when it comes to preparing for something like a cyclone?
It involves things like strengthening building codes to withstand high winds and flooding,
Right.
investing in early warning systems to give people more time to evacuate,
Okay.
and just generally educating communities about the risks and how to prepare for them.
So it's a multi-pronged approach that involves individuals, communities, and governments working together.
Absolutely.
What about the scientific side of things?
Yeah.
What can we learn from Alfred to improve our understanding and prediction of these events in the future?
Well, Alfred highlights the need for continued research into the complex factors that influence cyclone behavior,
Okay.
especially in regions like the Coral Sea, where predictions are notoriously difficult.
Yeah.
Gathering more data, refining our models, and improving our understanding of the interplay between the ocean and the atmosphere are all crucial.
So it's not just about reacting to cyclones when they happen.
No.
It's about proactively studying them, learning from them, and using that knowledge to better prepare for the future.
Precisely.
Ah.
And it's also about understanding that these events are becoming more frequent
Yeah.
and potentially more intense due to factors like climate change.
Right.
This requires a shift in our thinking
Okay.
from simply reacting to disasters to proactively building resilience
Right.
and adapting to a changing world.
It's a call to action, isn't it?
Yeah, I think so.
To learn from events like Alfred, to adapt our strategies, and to build a more resilient future. What role do you see technology playing in this effort?
I think technology is an essential tool. Satellites like the one that tracked Alfred are crucial for monitoring these storms, collecting data,
Yeah.
and making accurate forecasts. And with advancements in computing power and artificial intelligence, we're now able to process and analyze vast amounts of data more effectively,
Wow.
leading to better predictions and potentially saving lives.
So it's about using technology not just to understand what's happening, but also to predict what might happen and to inform our decisions about how to best prepare and respond.
Exactly. And it's also about using technology to communicate effectively with the public.
Right.
Getting timely and accurate information to people in the path of a storm can make all the difference in terms of preparedness and safety.
It sounds like we've covered a lot of ground here.
Yeah, we have.
From the specific details of Cyclone Alfred's path and impact to the broader questions about climate change, resilience, and the role of technology.
It's a complex story with many interconnected layers.
Yeah.
And I think one of the key takeaways is that while we can't control the weather,
Right.
we can control how we prepare for it
Right.
and how we respond to it.
So even though Alfred may have been a rule breaker,
Yeah,
it served as a valuable lesson highlighting the importance of ongoing research community preparedness
absolutely.
and adapting our strategies in the face of a changing climate.
It's a story that reminds us that nature is a powerful force, and we need to respect its unpredictability while also utilizing our knowledge and tools to become more resilient in the face of these challenges.
Yeah, it really highlights the fact that we're all in this together when it comes to dealing with these extreme weather events.
Absolutely. From like these scientists who are, studying cyclones
Right.
to the communities preparing for them and the emergency responders helping in the aftermath,
Yeah.
everyone has a role to play.
And we need to keep learning and adapting our strategies because as we've seen with Alfred, nature can still throw us some pretty big curveballs.
That's right. Even with all of our advancements in technology and forecasting, we're still dealing with these incredibly complex systems.
Right.
There's always more to learn and ways we can improve.
Events like Cyclone Alfred, as destructive as they are, can also provide us with valuable data and insights.
Precisely. They push us to ask new questions, refine our models, and deepen our understanding of how these systems work.
All right.
We can learn a lot from each of these events and apply those lessons to future preparedness efforts.
So even amidst the chaos and disruption, there's opportunity for growth and learning.
Absolutely. And that's what makes these deep dives so fascinating.
Yeah.
We're not just looking at a single event in isolation, but exploring its broader context and implications.
As we wrap up our look at Cyclone Alfred, I'm left with this, sense of awe at the power of nature and a sense of urgency to learn from these events and build a more resilient future.
I think that's a perfect way to put it.
Yeah.
The story of Cyclone Alfred isn't just a story of destruction.
Right.
It's also a story of resilience, adaptation, and the ongoing quest to understand our place in a constantly changing world.
It leaves us with some pretty big questions to ponder.
Yeah.
How do we navigate this changing world, prepare for the unexpected, and build a future where we can thrive in the face of these challenges?
These questions will continue to drive our exploration, innovation, and collective efforts to build a more sustainable and resilient world.
Yeah.
We can't just wait for these events to happen. We have to be proactive in our approach.
And for our listeners out there, we encourage you to stay curious, keep learning, and engage in these important conversations.
The more we understand about our planet and its complex systems, the better equipped we'll be to face whatever challenges come our way.
Cyclone Alfred may have broken all the rules.
Yeah, it did.
But it also gave us a valuable opportunity to learn and adapt.
Absolutely.
And that's where the real story begins.